we did not discuss this one, no? Goodness of fit. Can you understand? I think we'll have to start from here, no? Hello. Did we discuss this one?
I don't think so, doctor.
Okay. Okay, then today our discussion is about goodness of fit. That means once you estimate regression model, you have to test whether the model is good or bad. To test goodness of fit, we have one indicator. That indicator is called R square. It measures the percentage of total variation of the dependent variable that can be explained by the independent variable. The R square measures the percentage of total variation of the dependent variable that can be explained by the independent variable. That is the definition for R square. And then let's see what is the goodness of fit. Then now you may have idea about simple regression model. Now let's say this is X, this is Y. Okay. Now let's say these are the actual observations. Okay, these are the actual observations. That means if the value of X is this much, Y is this. These are we call actual value, or we can say Y is the actual value. Y is equal beta 1 plus beta 2 X plus error term. This is the Y. And then let's assume we estimate the regression model. The model is something like this. This is we call Y hat for estimated value. Y hat is equal beta 1 plus beta 2 X. Then we can say this is beta 1 hat, beta 2 hat, that means the estimated value. Then the difference between Y and Y hat is we call error term Y minus Y hat. This is we call error term. Now let's say this is the model 1. Now let's say I draw another model. Let's say actual values are like this. Okay. Then the regression line we estimate is, let's say, like this. This is the Y hat. Okay. Let's say this is Y hat 2, this is the Y hat 1. So model 1 and model 2. Then now I am going to ask a question from you. Now here you can see two regression model 1 and 2. Which one is good model? Model 1 or model 2? Which one is good according to your understanding? Yes, one say model 1. How about others? Yes, model 1. Why you say model 1 is good? Why model 2 is not good? Yes,
The line is closer to the observations or scatter plot.
that means our in the model 1, the regression line, the actual values are close to the regression line. In other words, you can say, how about the error terms? Errors. If you compare these two, which one has more errors? No, model 2 has more errors. Error mean y minus y hat. Y is this value, y hat is this. The difference between actual observed value and the estimated value. Okay. Now in the model 1, error term is small compared to the model 2. Then you can say model 1 is good, model 2 is not good. Why it is not good? It has a higher error term. It shows that the model does not explain significant proportion of variation of y with the regression model. Okay. Now this is the actually basic idea about goodness. These three concepts are total sum of square, explain sum of square, and residual sum of square. There are three things. Okay. Total sum of square is equal, explain sum of square, residual sum of square. Then you should know about these three concepts. Let me explain total sum of square. Then our dependent variable is y. Dependent variable is y. The variation of y mean it shows how each y value deviate from average of y. The difference between y and average of y. Then you get the square of it. not sorry, now you get the sum of it. This shows the sum. You add all these values. Then if you take yi minus y bar, some values are plus, some values are minus. Then this will become 0. That's why we take the square of it. And it is we call total sum of square. Then this shows how y value of y deviate from mean value. Value of y deviate from mean value. We will do the one example later, then you can understand clearly. Okay. Then this is the total variation. Then we have another concept called explain variation and residual sum of square. Actually, you know what is the residual? What is the residual? Error term is equal y minus y hat. Error term is equal y minus y hat. Then the residual sum of square means the difference between y and y hat, okay, and the square of it, and you get the summation of this. This is the we call residual sum of square. Residual sum of square. Then what is the explain sum of square? It is equal to this. That means it is equal y bar, sorry, y hat minus y bar square of it. And you get the summation of this. This is we call explain sum of square. This shows the proportion of total variation explained by the regression model. Is it clear? Let's say this is y bar, okay? And this is y hat. Then we consider this as a one observation. This is the value of x. Okay. Then this is the y hat. Let's assume some values. Let's say here 20. Here let's say 25. Here let's say 35. Okay. 35. That means now if I write down here, when x is equal to, let's say 5, x is equal to 5, y is equal to 35, y hat is equal to 25, then the y bar is equal 20. Okay, y bar is equal 20. Then for this observation, what is the total variation of y? Total variation of y is y minus y bar. Y minus y bar. Then for this example, y is equal 35, y bar is equal 20, then the variation of y is equal 15. Is it clear? That means this area. Then explain variation. Y hat minus y bar. What is the y hat? 25. What is the y bar? 20. Then the explain variation is equal to 5. That means now you can see here this is the total variation. Out of this total variation, this amount has explained by the regression model. Then what is the residual for that data point? The residual is, we know y 35 minus y hat. Y hat is 25. It is equal 10. Then now you can see the total variation is equal to sum of explained variation and unexplained variation. If you add these two. Like this, you can calculate variation, explained variation, and residual for each and every observation like this. If you have many observations, for each and every observation you can calculate. Then you can add. Then if you add, it is we call total sum of square. And explain sum of square and residual sum of square. Then you can see TSS mean total sum of square. Okay. Now we can divide this equation TSS equal ESS RSS. This I divide by TSS. If you divide by TSS, it equal 1. Okay, 1. Then ESS over TSS. What does it mean? ESS over TSS. ESS mean explain variation. TSS mean total variation. This shows percentage of total variation or proportion of total variation explained by the regression model. Okay, if you assume TSS is 15, ESS is 5, and RSS is 10, then what is the answer here? ESS is 5, TSS is 15, then RSS is 10, then the 15. Then this shows proportion. This shows proportion of total variation. Total variation is 15. Proportion of total variation explained by the regression model. This is we call R square. This we call R square. Then this shows proportion of total variation not explained by the regression model. Okay, this we call R square. Is it clear up to this point? Okay, then you can see here R square is equal ESS over TSS. The main criteria of goodness of fit, formally described as the coefficient of determination, but actually referred R square, is defined to be the ratio of ESS to TSS. That is the proportion of variation of Y explained by the regression equation. Is it clear? Hello, please.
Yes, sir.
Okay.
Yes, sir.
Then in the next slide, now this shows how R square appear in regression output. Then if you run a regression model, okay, then R square you can see here. This is the value of R square. Then you should know how to interpret R square. Then what is the interpretation of this value? We know R square shows the proportion of total variation explained by the regression model. Now in this example, R square is 0.0855. Then what is the proportion of total variation explained by the regression model? Only 0.085 proportion has been explained by the regression model. You can see here. Yes. Now this shows actually how we get this value again. Now we know R square is equal explained sum of square divided by total sum of square. Now here this is the total sum of square TSS. This is the ESS explained sum of square. This is the RSS residual sum of square. RSS. Okay. Then sum of these two is equal to this. Then R square is equal this value divided by this. The R square is, if it is above 0.5, then the model is good. We can say if the R square is above 0.5, then the model is good. Now in this case, value of R square is 0.85, then we can say only 0.85% or only 0.85 proportion of total variation of y has been explained by the regression model. Is it clear up to this point?
Yes, sir.
Now, obviously, we would like to locate the regression line so to make the goodness of it as high as possible according to this criteria. Does this objective clash with our use of the least square principle to determine beta 1 and beta 2? What is the principle of least square method? The principle is with the minimum errors. Okay. Now you can see another equation for r square. Another equation for r square. How we get this equation? How we get this equation? Actually, here you can see ESS. ESS, TSS equal ESS plus RSS. Then you can rearrange this TSS minus RSS equal ESS. No? Then we have substitute here. And also if you further rearrange this, you can get this. Further rearrange mean you have divide TSS by TSS minus RSS by TSS. This is the RSS. Then you can see the model or R square is value of R square is increase if the residual sum of square decrease. The main principle of the OLS estimate is to minimize residual sum of square. Then if you can get the minimum residual sum of square, you have a model with high value of R. Is it clear? The OLS coefficients are chosen in such way to minimize sum of residual of sum of square of residue. This is automatically follow that they maximize R square. That means once you minimize residual sum of square, your R square will maximize. Then another important criteria is the relationship between actual value and the predicted value. Okay. Then if the model is good, there should be a correlation between actual value and the predicted value. there should be a correlation between actual value and the fitted value. Actual value mean the value in our data set. Fitted value mean the predicted value. Now this formula shows how to calculate correlation coefficient between y and y hat. Y is actual value, y hat mean predicted value. Now this is the formula. Okay. Now this formula you can summarize like this. Now y hat minus y bar, yi minus y bar square, that means this is the total variation, this is the explained variation, square root of this. Then this is the r square. Then now you can see here correlation coefficient is equal to square root of r square. Square root of r square. That means if the correlation coefficient increase, the value of r square also increase. What do you mean by correlation coefficient increase? If the correlation coefficient have higher value, it shows that there is a relationship between actual value and the observed value. Both change into same direction. Then the model is good. These are the things that you should know about R square. Is it clear? Should I explain more? Okay, then we can do quick exercise. Okay, I share one data set in WhatsApp group. Please check it. Hello, I share a data set in.
Yes, sir, we
Uh,
received.
okay, okay. Then the same thing is here. Okay, now here you can see a data set Y and X. Let Y stand for supply, X stand for price. Okay. Then you can run a regression model, data analysis, then the regression, then the input variable Y, input variable X, then okay. So, and this is the average. We should give up this data, regression, then we select, then okay. Because this 63 and 9 is the average value. Okay. Then you can see the regression results. Okay, then you can see here R square, value of R square is this. And also this is the TSS. This is the RSS. This is the ESS. Then you can see here R square is equal ESS explain variation divided by TSS mean total variation. Okay. Then I'm going to further explain how you can get TSS, RSS, and ESS. Then here you can see the data set in another sheet. Sheet 2. Okay, then this is the Y, this is the X. This is the average of Y. Average of Y mean Y bar. This is the Y bar. Then the predicted value mean y hat. Residual mean error term, let's say E. Okay. How to get this predicted value? I'll show first one. Now this is the regression line. Okay. Then the y hat is equal 33.75 plus 3.25 x. Then here x value is 9. Then you insert here 9. Then you can see y hat is equal then 63. Check whether you can get the same answer. How to get this answer? 33.75 plus 3.25 into 9. 63. Okay. 63. Then predicted value is 63. Then what is the residual? How to calculate residual? The residual is equal y minus y hat. Value of y is 69. Residual is 60. Y hat is 63. Then residual is 6. Is it clear? Then this is the residual sum of p square. Residual sum of p square means residual square of the residual. That means 6 square. Then this is the explain variation. This is the unexplained variation. Now explain sum of p square. Then y explain variation is 0. How to get explain variation? Explain variation mean y hat minus y bar. What is the y hat here? Y hat value is predicted value 63. Y bar also 63. Then the explain variation 0. Then explain sum of p square mean the square of 0. Then total variation. Total variation mean y minus y bar. What is the y? 69. Y bar 63. Then it is 6. Sum of square mean square of this. Okay. Then like this, you can calculate residual, predicted value, explain variation, total variation, residual sum of square, explain sum of square, and total sum of square. All these values are here. Then when you add all these residual sum of square, that means when you add all these values, okay, you can have residual sum of p square. You can have residual sum of p square. That means you can see here sum of these values is the residual sum of p square. See, same value is here. Then this is the total explained variation. Sum of this same value is here. This is the total variation. Okay. Then now you can see how to calculate these values and how to calculate R square. Is it clear? Hello.
Yes, it's
Okay, then you can study this table. Okay, then only you can understand clearly. Then shall we have 10 minutes break? Then after that, I will discuss how to conduct hypothesis testing for the regression option. Meantime, you can study this table further. Is it okay? Shall we
okay,
start
sir.
around 11:30? Maybe 8 minutes break. Hello, I hope you can see the screen. Can you see the screen? Hello. Can you see the screen?
Yes, sir.
Okay, then the next session is about hypothesis testing, where you are going to learn how to test the significance of regression coefficient. For the statistics subject, you learn how to conduct hypothesis testing for mean. Now here you can see one example or review chapter, mean the things we learn for uh, things we learn for.
Excuse me, doctor, we can't see the presentation. We can see your,
That's why I asked.
we can see the folder.
Okay, okay. Then one told that they can see. Now can you see?
Yeah, doctor.
Okay, okay. Thank you. Okay, our topic is about hypothesis testing. The basic concepts related to hypothesis testing we learn for financial statistic course module. Then if I review how to conduct hypothesis testing for population mean, this is the population mean, this is the population standard deviation. Okay, these are we don't know values. From the sample, you can estimate sample mean. Using this sample mean, you can test some value for population mean. Let's you assume population mean is equal to this value. Let's say as example, we can consider this MFE group as a sample. Let's say average age is 35 from the sample. Then you want to test whether population mean is equal to 40 or whether it is not equal to 40. Okay, this is this value. Then you have an assumption population mean is equal to 40. Then the alternative is population mean not equal to 40. Then this is we call test statistics. Okay. X bar is from sample, population, mean, standard error of the mean. Then this is the rejection criteria. T critical value mean this one. T absolute value mean this. That means if you put these two lines, this shows the absolute value. If the absolute value is greater than critical value mean from the table, we reject HO. Then a similar technique you can use for regression. Now we estimate regression from the sample. Then the estimated regression coefficient is beta 2. This is the formula we have to use. Then we want to test whether this beta 2 is equal to some value or not equal. Now this is the formula. Then if the T critical value greater than this, then we accept. We reject the null. Okay. Then I think you better write down these things. Y equal this one and these two and this. Then the degrees of freedom, when you read the T table, degrees of freedom is here n minus 1, here n minus k. That means n is the number of observation, k is the number of parameters, b1 and beta 1 and beta 2. Okay, then we have one example here. Let's say we have a regression line. Here P stand for inflation, W stand for wage. Then we have assumed P inflation is a function of wage increase. Okay. Then if the wage increase, what will happen to the price? Price also increase. How? When the wage increase, then the demand for goods increase. When demand for good increase, if the supply does not increase, then the price will increase. Now let's say you want to test whether there is an exact relationship between P and W. That means, let's say you want to test whether wage increase by 10%, price also increase by 10%. You assume that if wage increase by 10%, price also increase by 10%. That means when wage increase by some percentage, price also increase by some percentage, you assume. If this is the situation, then this beta 2 value should be equal to 1. If the price will increase by same percentage as wage increase. Okay. Then your null hypothesis is beta 2 equal 1. Alternative hypothesis is beta 2 not equal 1. Okay. Then how to test this? Then you can estimate the regression model. Let's say the estimated model is like this. Value of beta 2 is 0.82. Then these values in a bracket called standard errors. Standard errors. Then now you want to test whether you are going to accept this hypothesis or whether you are going to reject. Okay. Then here we have to compute test statistics, so T statistics. Then the T statistic is equal 0.82 minus 1, this. I hope you can understand it. Then here sample size is 20. Sample size is 20, it is given. Then the degrees of freedom is 18. Then this is from T table. I will explain how to get it. T table at 5% level of significance, it is 2.101. Okay. This is the critical value. Okay. Then what is your decision? The critical value of T with 18 degrees of freedom is 2.101 at 5% level. The absolute value of T statistic is less than this, so we do not reject. Null hypothesis. That means T value, absolute value T critical value is this. Then the absolute value is 1.80. Critical value is 2.101. Then this is less. Then we do not reject. We reject the null if the test statistics absolute value is greater than T critical. That means now we do not reject, mean we accept this. That means at 95% confidence level, we can say there is a one-to-one relationship between price and inflation. When the price increase, when the wage increase by some percentage, price also increase by same percentage. Is it clear? No. If you have any doubt, you can raise, okay? Then we will move to next section. Now let's say here we have a regression model. Y is a function of X. Okay. Let's assume value of beta 2 is 0. If the beta 2 is 0, are there any relationship between Y and X? If the beta 2 value is 0, are there any relationship between X and Y?
No, sir.
No, there is no any relationship between X and Y. Okay. Then you can use hypothesis testing to test your null hypothesis is, let's say, beta 2 equals 0. Your alternative is beta 2 not equal 0. Okay. Then if you accept this one, that means there is no relationship between X and Y. If you reject this, you accept this, that means there is a relationship between X and Y. Now I am going to explain how to do this test. Then we assume beta 2 equals 0, beta 2 not equal 0. Then the test statistic is beta 2 value minus beta 2 means 0 then the standard error. If you assume this value is 0, then test statistic is equal beta 2 divided by standard error of beta. Then you can see here regression output. Okay. Now in this regression output, our regression model is earning as a function of schooling. Then if you put y is equal 0.76 plus 1.26x. Y is earning, x is schooling. Then this is the standard error. Then we can write the model like this: y equal beta 1 plus beta 2x. Then what is the beta 2 value? This is the value of beta 2. This is the standard error of beta 2. Okay. Then now you want to test whether the coefficient related to schooling is significant. That means whether it is significantly different from 0. Then how to do this one? Then you have to develop null and alternative. What is your null? Null is h0 beta 2 equals 0, h1 beta 2 not equal 0. Okay. Then what is the next step? Calculate the t value. T value is beta 2 divided by standard error of the beta 2. What is the beta 2 value? 1.2, this value, divided by standard error. Once you divide this, you can see it is equal to this. Six point eight. 6.8. Okay. Then you have to take the critical value. Actually, in this example, as number of observation is 500, we can go for Z table. 5% level of significance, the T critical value is 1.96. 1.96. Then now you can compare T value with the Z critical value. Z value is 1.96, T value is 6.82. Then it is high. Then you reject the null. You reject the null, you accept that beta 2 is not equal to 0. That means there is a relationship between earnings and school. This is the way to conduct hypothesis testing. Okay. Then if I further explain this, now if you are given the regression output, it is very simple to understand whether the coefficient is significant or not. This is the coefficient. These are the coefficient. beta 2, and beta 1. It is very simple to identify beta 2 is significant or not. Standard error is given here, t is given, t mean this value divided by this. Okay. And this value is, this is divided by this. Then here you can see p value and the t critical value. Actually here p value mean, when we discuss stat, we know the p value is the minimum level of significance where you can reject it should. If the p value, okay, is less than the level of significance, we reject the null. We reject the null. What is the level of significance? You can decide it. Let's say level of significance is 5%. If the level of significance is 5%, and if these values are less than to the 5%, 0.05, then you reject the null. Now in this example, you can see p value is 0.00. It is less than the p value. That means we reject the null. That means we accept that beta 2 is significantly different from 0. But how about the beta 1? Is it significant or not? Yes, any answer? Beta 1? At 5% level of significance, whether beta 1 is significant or not. Hello? Beta 1, is it significant or not? It's very simple how to check. If this p value is greater than level of significance, it is not significant. Now, for the beta 1, p value is 0.785, which is greater than the level of significance. Then this is not significant. That means we accept beta 1 equal to 0. That means it is not significant. Is it clear? This is the way to conduct hypothesis testing. You can see T statistic for the coefficient S is enormous. That means this value. You would reject the null hypothesis that is pooling does not affect earning at 1% level significant. Whose critical value is 2.59. If it is a 1%, the critical value from the Z table, it is 2.59. In the case we could go further and reject the null hypothesis that is pooling does not affect earning at 1%, 0.1. That means this p-value shows the minimum level of significance where you can reject it. Then if it is a 0, it indicates that even at 0.1%, also you can reject the null. The advantage of rejecting at 1% level instead of 1% is that risks of mistaking rejecting null hypothesis of the no effect is now only 0.1 instead of 1%. That means we have learned type 1 error and type 2 error. If you can reject the null at very small level of significance, then there is a small or very small level of probability to have a type 1 error. Okay, then this is the end of discussion related to hypothesis testing. Then you can read and understand further. And I can share one textbook with you in the WhatsApp group. Then you can read that textbook to get further understanding about these concepts. In the next week, I will discuss confidence interval estimation. Then if you have any doubt up to this point, you can raise. Check whether you can open that book in the chat box, not the chat box, WhatsApp group.
Yes, sir, we can open.
Okay, then in this book, actually now we discuss simple linear equation. Can you see it now? We have Chinese version also here. These things we discuss, and Then you can see the confidence interval. We will discuss in the next session. Then this is the hypothesis testing we discussed today. See, then you can read and understand this. Okay. Okay, then shall I wind up the session? Please prepare this book, then you can understand the things we discuss very easily. Okay, then see you next week.
Thank you, sir.